All right, let's jump right in. We're surrounded by buildings every single day, but have you ever stopped to think about what's really holding them all together? In this explainer, we're going to break down the basics of traditional construction. It sounds like a simple question, right? But the answer is actually pretty fascinating. It's not just about bricks and windows. There's this hidden world of engineering that keeps these massive structures standing tall, sometimes for centuries. And the secret to all of it is the structural frame. The best way to think about it is this. Every single building has a skeleton. And just like skeletons in the animal kingdom, they come in all different shapes and sizes. Today, we're going to look at the four main types. So, let's get right to the heart of it. What is this skeleton and what does it actually do? Here's the deal. The frame's main job is to take all the weight, we're talking the roof, the floors, the furniture, even us inside, and channel it safely down into the ground. It has to be strong enough to fight off forces like wind and gravity. Without that frame, you've basically just got a big pile of materials. Okay, so now we know what a frame does. Let's dig into the four most common methods you'll see in traditional construction. Each one has its own unique story, its own special strengths, and of course, its own look. We're going to start with the oldest of the bunch, the timber frame. When you see one of these beautiful old buildings with its exposed wooden beams, you're looking at a building technique that is literally hundreds of years old. The real magic here is the sheer craftsmanship. We're not talking about nails and screws. This is all about massive wooden beams fitted together with these incredibly precise cuts called mortise and tenon joints. They're locked in place with wooden pegs. It's kind of like a giant, super strong puzzle. This method, which has been around since medieval times, creates a structure that's not only strong, but can also flex and settle over the centuries without falling apart. All right, let's fast forward a few hundred years to the 20th century and talk about the concrete frame. This stuff completely changed the look of our cities. It allowed architects to create shapes and structures that were just impossible before. So here's a fun fact about concrete. It's amazing when you squeeze it, but not so great when you try to stretch or bend it. That's where rebar comes in. Those are the steel reinforcing bars. Workers build temporary molds on site, which are called formwork, stick the steel rebar cage inside, and then just pour in the concrete. The result? A single solid structure of columns and slabs that's incredibly strong, super durable, and really good at resisting fire. And from concrete, we move on to its bigger, stronger cousin, steel. If you want to build big, create huge open spaces, and get it done fast, the steel frame is what you're looking for. This is the true skeleton of the modern skyscraper. What's really cool about steel is how efficient it is. The different parts are made with incredible precision in a factory, then they're just brought to the construction site and bolted or welded together. This makes building so much faster, which is a huge deal for big commercial projects. And because steel is so strong for its weight, architects can go wild, designing these massive open-plan spaces without a bunch of columns getting in the way. Okay, our last method is a little different from the others. See, with timber, concrete, and steel, you have a separate skeleton doing all the heavy lifting. But with masonry, the walls are the skeleton. If you've ever been to the UK, you've seen this a million times. It's the classic way to build a house. It uses this really clever system called a cavity wall. You've got an inner wall, or leaf, made of strong concrete blocks that actually holds the building up. Then there's an outer wall of bricks that acts like a raincoat, protecting everything from the weather. And that little gap in the middle? That's for insulation. It's a tough, time-tested method that's fantastic for keeping homes warm and quiet. All right, so let's do a quick rundown. We've got timber for that beautiful, historic craftsmanship, concrete for its versatile, moldable strength, steel for when you need speed and massive scale, and masonry for those solid, reliable homes. 4 different skeletons, all for very different kinds of buildings. Okay, so we've covered how buildings stand up. Now let's talk about how high they can go. Because, as you can imagine, the type of skeleton you choose often depends on just how big you're planning to build. Let's start with what we see most often. Low-rise buildings. We're talking anything between 1 and 4 floors high. Yep, this right here is a low-rise building. This category includes most houses, schools, and smaller shops. They tend to be built with masonry or timber frames and feel much more connected to the street level. Moving up a level, we have mid-rise buildings, which usually falls somewhere between 4 and 12 floors. And this is a mid-rise. These are becoming super important in cities. They're a great way to house more people without building these giant, overwhelming towers. They really strike a nice balance, creating lively neighborhoods that still feel personal and easy to walk around in.
And finally, we get to the big ones, the high-rise category. This is pretty much any building that has 12 floors or more.
This is a high rise. Now, anything with 12 or more stories gets put into a special category. In the UK, they're officially classified as higher risk buildings, and for good reason. They have to follow the absolute strictest safety standards, especially when it comes to fire safety and making sure the structure is sound.
So we've looked at the skeletons and the different sizes of buildings. What's the big takeaway here? What does it all really mean?
Well, it really all comes back to that one idea, the skeleton. Whether it's made of ancient wood or modern steel, that structural frame is the single most important part of any building. It shapes everything, not just how strong it is, but what it feels like, what it's used for, its entire personality, really.
And that leaves us with one last big question. As we look to the future with all its challenges, a growing population, a changing climate, the skeletons we choose for our buildings are going to be more important than ever. So the question for all of us is, what will the skeletons of our future cities be made of?